Much of our interaction with the modern web is done through web-based applications. LinkedIn Learning is a great example of this. You log into a website or an app and gain access to a wide variety of features within that application. Now, these apps are typically centralized, meaning the data stream in and out of the application goes through the app provider. On Web3, where decentralization is the name of the game, this type of application becomes a decentralized app, more commonly referred to as a dApp. A dApp comprises smart contracts on the decentralized blockchain. Think of these as the API layer, and front-end user interface and back-end data store hosted on decentralized storage services. When you interact with a dApp, you're accessing the front-end interface, and that interface then communicates with the smart contracts on the blockchain. The smart contracts operate as the de facto API for the blockchain and for decentralized storage and control how you work with the data on blockchain and in the storage. So combined, the dApp makes the rather complex operation of doing things on the blockchain and in decentralized storage easier, which is why the idea is so popular. So if we strip all the jargon away, a dApp is a user-friendly interface for the blockchain and for decentralized storage. Nothing more, nothing less. For a dApp to be truly considered a dApp, certain conditions must be met. First, it must be decentralized. This is achieved by placing the smart contracts on the blockchain and the front end and data store on decentralized storage. Second, it must be deterministic, meaning the dApp performs the same function no matter what environment it's executed in. That way, it doesn't matter if the front end you use is web-based or an app on your phone or something else. The same input always produces the same output or result. Third, it must be Turing complete, meaning it can perform any action it's set up to perform, provided it's given enough resources. And finally, it's isolated, meaning the operation or malfunction of a dApp is not impacted by and does not affect any other dApp or entity in the same system. This is especially important since the dApp lives on the blockchain. The benefits of a dApp are obvious. Decentralization offers persistency, data security, and integrity, and, if it's set up to do so, privacy and resistance to censorship. On the other hand, there are some obvious drawbacks. Smart contracts on the blockchain are difficult and expensive to update. A new contract must be added to nullify the previous one, meaning the traditional incremental updates we see in Web 2.0 apps will be much more difficult to roll out. Because the backend of a dApp is hosted on the blockchain, all standard blockchain challenges, including scaling, network congestion, network cost, etc., all come into play. Also, building seamless and easy-to-use user interfaces and experiences on top of the blockchain has proven to be very difficult because of everything from the need to exchange public and private keys to significant network lag. And the most obvious solution to these issues all involves some form of partial or complete centralization, which breaks the first requirement for a truly decentralized app.